We want to find the first 5 terms of each sequence given the sequence formula or rule, and then also find the 10th term. Let's start with a quick review. A sequence is an ordered list of terms or elements where the number of terms can be finite or infinite, meaning we can have a certain number of terms or we can have an unlimited number of terms. But more formally, we can also think of a sequence as a function, a of n or a sub n, where the domain n is the counting numbers or natural numbers. So for an example, here's a sequence. Again, we have an ordered list of terms. This sequence is generated using this function or this sequence rule or formula, where again n is the domain, which consists of the counting or natural numbers, and a sub 1 represents the first term in the sequence, a sub 2 represents the second term in the sequence, a sub 3 represents the third term in the sequence, a sub 4 represents the fourth term in the sequence, and so on. So notice for a sub 1, n is equal to 1, so we substitute 1 for n in the formula to generate the term. Notice 2 times 1 plus 1 is equal to 3. To find the second term, or a sub 2, we substitute 2 for n. For a sub 3, we substitute 3 for n. And for a sub 4, we substitute 4 for n. So going back to our examples, if we want to find the first 5 terms and the 10th term, we need to find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and also a sub 10. So to find a sub 1, we'll substitute 1 for n, and then evaluate the function or formula. For a sub 2, we'll substitute 2 for n. For a sub 3, we'll substitute 3 for n, and so on. So a sub 1 is equal to negative 2 times 1 plus 5. Negative 2 plus 5 is equal to positive 3. Again, notice how we substituted 1 for n. And now to find a sub 2 of the second term, we'll substitute 2 for n. So we'll have negative 2 times 2 plus 5. This would be negative 4 plus 5, or positive 1. And now we'll just keep doing this, subbing in different values for n. So notice if we know which term we're looking for in the sequence, this gives us the value of n. So let's go ahead and finish evaluating these. A sub 3 is equal to, this would be negative 6 plus 5, or negative 1. A sub 4, the fourth term, is equal to negative 8 plus 5, or negative 3. A sub 5 is equal to negative 10 plus 5, or negative 5. And then a sub 10, the 10th term, is equal to negative 20 plus 5, which is negative 15. Let's go ahead and write this as a list. So we have 3, 1, negative 1, negative 3, negative 5. And we didn't find the 6th, 7th, 8th, or 9th term, but the 10th term is negative 15, and the sequence would continue. This is actually called an arithmetic sequence because to find subsequent terms in the sequence, we're adding a constant value. In this case, we'd be adding negative 2 each time. If we want, we can say we're subtracting 2 each time. Notice 3 minus 2 is equal to positive 1. Positive 1 minus 2 is equal to negative 1. Negative 1 minus 2 is equal to negative 3, and so on. Again, this is called an arithmetic sequence. Let's go and take a look at our second example. It's the same question, but now we have a sub n is equal to 2 times 3 raised to the power of n. So again, to find the first 5 terms, we want to find a sub 1 through a sub 5. The 10th term would be a sub 10. So looking at our sequence formula or sequence function, we'll be changing the value of n here and here to find our terms in the sequence. So a sub 1 will be 2 times 3 to the first. A sub 2 would be 2 times 3 to the second. A sub 3, the third term, would be 2 times 3 to the third, and so on. Again, notice how each term we're looking for gives us the value of n, which is what we substitute into our sequence formula. Now we'll go and evaluate these to find the actual terms. 3 to the first is 3, times 2 would be 6. 3 to the second is 9, times 2, that's 18. 3 to the third is equal to 27 times 2, that's 54. 3 to the fourth is 81 times 2, 162. 3 to the fifth is equal to 243 times 2 would be 486. Let's go and use a calculator for this last one. We have 2 times 3 raised to the 10th power, which is 118,098. Let's go ahead and give this as a list. We have the first term, second term, third term, fourth term, fifth term. And again, we didn't find the 6th, 7th, 8th, or 9th term, but the 10th term is 118,098, and the sequence would continue. This is called a geometric sequence because to find subsequent terms in the sequence, we multiply by a constant. Notice in this case, if we start with 6 and we multiply by 3, we get 18. 18 times 3 is equal to 54. 54 times 3 is equal to 162, and so on. This shouldn't be surprising because notice as n increases by 1, we multiply by another factor of 3. Okay, I hope you found this helpful. We'll take a look at 2 more examples in the next video.